In this video, we solve a problem where we're told a pilot delivers supplies to a camp by flying 255 kilometers in the direction north 52 degrees east. While at camp, the pilot receives a message to pick up a passenger at a village. And then we're told the village is 85 kilometers south, 21 degrees east from the camp. What is the total distance that the pilot will have flown by the time he returns to his starting point? So let's go ahead and let's draw this out. And like I said, it's always a good It's always a good practice. I mentioned this in the previous video. It's always a good practice to draw out a diagram when you're given problems like these. So let's draw out. This would be north, south, west, and east. Okay, so the first piece of information that we're told is the pilot flies 255 kilometers in the direction of north 52 degrees east. So we're going to go, the pilot goes 255 kilometers north 52 degrees east. So 52 degrees east would be, let's draw it a little bit smaller. So this angle, north 52 degrees east, means you go north and then you go 52 degrees east. So this angle right here is 52 degrees. Now, then we're told while at camp, the pilot receives messages to pick up a passenger at a village, and the village is 85 kilometers south, 21 degrees east from the camp. So this is where the pilot starts. Let's say that he starts at point A, and then let's say that the camp is point C. So this is the camp. And from the camp, the pilot goes south 21 degrees east. So let's draw out another set of axes here. Now this is going to be east, north, south, west. Okay, so let's think about what we're told here. Well, we're told that the village is 85 kilometers south, 21 degrees east. So we're going to go 85 kilometers. Whoops, let me use a different color for this. So we're going to go 85 kilometers south, 21 degrees east. So it should look something like this. Now this angle right here is 21 degrees. And then we've got this point here. Let's call this point B. So we have triangle ABC. And it has angles A, B, and angle C. Okay, so what we're tasked with figuring out here is, and we know that AC, so I guess that would be side B. This dimension right here is 255 kilometers. Hopefully you can see that. That's 255 kilometers. So A to C is 255 kilometers. C to B is 85 kilometers. So this is 85 kilometers. And now we've got to figure out what our angles are. So I don't have any interior angles of the triangle right off the bat, but if I think about it, this angle C is going to be the sum of 21 degrees, because this little angle right here is 21 degrees, and this angle right here, because this angle and this angle are alternate angles. This angle between this white line and this line is 52 degrees, because these are alternate angles. So we have that angle C, let me use a different color for this. angle C is equal to 52 degrees plus 21 degrees. And that's because this angle here is 52 degrees, because 52 degrees and this angle are alternate angles, since this axis that I've drawn here is parallel to this axis. That's why these are alternate angles. And then this angle, this red angle that I drew over top of this one, was 21 degrees. So this big angle has to be 52 plus 21 degrees. And 52 plus 21 is 73 degrees. So now what we're actually asked to figure out is what is the total distance the pilot flew. So the pilot flew from the start, which I've got drawn here at the origin, from A to C, then from C to B, where this where the village is. So the village was 85 kilometers south, 21 degrees east from the camp. So that's at point B, and then back to point A is where the pilot returned. It asks what is the total distance the pilot flew. So here we have this this triangle, and we know these two sides. We have this contained angle. We know that angle C is 73 degrees. And what we're tasked with finding is this other side, AB. We want to know what this side is. And let's call that side X for now. Actually, I guess we can just label it as side C. So side C. So we know that using the cosine law, if we use the cosine law, we know that C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. And we know what angle C is, we know what A is, and we know what B is. So C squared is equivalent to A squared, which is 85 squared, plus B squared, and B was 255. So plus 255 squared, minus 2 times 85 times 255 times the cosine of 73 degrees. And now we can go ahead and we can solve for C, because C is just equivalent to the square root of all this. So if I wanted to, I could actually just solve for C in one step. I could just say that C is equivalent to the square root of this. Oh, whoops. So C is equivalent to the square root of all this. And if you do this on a calculator, you'll find that 85, let's do 85 squared plus 255 squared. And I do recommend that you actually try this problem out on your own, because you wouldn't believe how many times students have asked me while they're writing an assessment, sir, how do I perform this operation on my calculator? So it's really important that you practice doing this with your own calculator, and you do actually verify this on your calculator. So we find that C is approximately 244 meters, or sorry, kilometers rather. So therefore A plus B plus C is equivalent to it's equal to 85 kilometers plus 255 kilometers plus 244, which is equal to 85 plus 255 plus 244 is 584. And since we're at the end of the problem, we should write a therefore statement. Therefore, the total distance traveled the total distance traveled is, or was, I guess, 584 kilometers. Now, something to note here is generally when you write an assessment, it will tell you what to round to in the problem. And since here it wasn't specified, I just rounded to the nearest kilometer. But definitely on an assessment, it'll say what you should round your answer to, what value you should round your answer to.